So next we are going to see Gauss's law and its applications. So before going to Gauss's law, so you know what is meant by flux and all those things. So we can now see what is meant by electric flux density. So you can see a figure. So consider two point charges plus Q and minus Q. The flux originating from positive charge and terminate from negative charge. So you know all those things. Consider a unit surface area. You can consider unit surface area. The flux lines are passing through the unit surface area. The net flux passing normal to the unit surface area is called a flux density. It is denoted as D, vector D. It has a specific direction which is normal to surface area. So it is a vector field. So Michael Faraday conducted an experiment with concentric conducting spheres insulated from each other. The inner sphere was given a non-positive charge. This sphere was then covered with a spherical shell of dielectric material. And this setup was then covered by a spherical conductor. So the outer sphere was earthed momentarily. So after the outer sphere was removed and measured the amount of total charge on it, this charge was found to be equal and opposite to the charge on the inner sphere for all sizes of the sphere and all type of dielectric media between the sphere. So Faraday suggested that an electric displacement has occurred from the inner to the outer sphere to dielectric medium. The amount of this displacement, say psi, depends only upon the magnitude of charge Q on the inner sphere. It is known as displacement flux or electric flux. So electric flux will be is equal to the charge that producing it. That is psi will be is equal to Q. So you can consider an inner sphere of radius A and outer sphere of radius B with charge of Q and minus Q. So here the charge is Q and here it is minus Q. The path of electric flux psi extending from inner sphere to outer sphere are indicated by flux lines drawn radially from one sphere to other. Thus D on the surface of the inner sphere will be is equal to psi by 4 pi r square, that is flux by area. Area of spherical is conductor is 4 pi r square. So 5 by 4 pi r square will be equal to Q by 4 pi a square. Because it is A, the radius is A, inner sphere the radius is A, psi will be equal to Q. So D on the surface of the sphere, surface of the outer sphere, that is psi by 4 pi b square into vector AR, that is Q by 4 pi b square into vector AR coulomb per meter square. And at a radial distance R, that is in between A and B, anywhere in between A and B, that is at a radial distance R, D will be is equal to Q by 4 pi r square into vector AR. So if now the inner sphere becomes smaller and smaller while still retaining a charge of Q, it becomes a point charge. The electric flux density at a point r meter from point charge is given by Q is equal to Q by 4 pi r square into vector AR. So we know that the electric flux density due to a point charge is given by D is equal to Q by 4 pi r square into vector AR. So we also know that the electric flux density due to a point charge is given by E is equal to Q by 4 pi epsilon 0 r square into vector AR. From this we can say that D will be is equal to epsilon E, epsilon 0 E for free space, and D will be is equal to epsilon E. Electric flux through a differential area ds is D psi will be is equal to D dot ds. That is electric flux will be is equal to D dot ds. That is psi will be is equal to surface integral D dot ds. So next we can see what is going to be a solid angle. So if the S is the surface area of the patch on a spherical surface of radius r, then the solid angle subtended the center of the sphere by this patch ohm will be is equal to S by r square. For a differential area, d ohm will be is equal to ds by r square. So you can see this sphere is a part of a spherical sphere. So the d ohm will be is a part of a sphere. It's like a cone. D ohm. This angle will be d ohm. D ohm will be is equal to ds by r square. So if the small surface is not the part of a sphere, then we can take the projection on spherical surface. So this is ds and this is theta. You can say that the projection will be ds cos theta. This is the projection. So this will become ds cos theta. So d ohm will be is equal to ds cos theta by r square. And the total solid angle, always the total solid angle ohm will be is equal to, for a sphere it is 4 pi r square by r square, because surface area divided by r square. For a sphere the area is 4 pi r square divided by r square will be is equal to 4 pi z. This is very important. Total solid angle will be is equal to 4 pi, and d ohm will be is equal to ds cos theta by r square. Thank you.